Hi there, this is Saxon Math, Algebra 2, Lesson 36. This is, they give it a bunch of names. They're talking about contrived problems, multiplication of rational expressions, and division of rational expressions. We've already done these. So basically, ratio is just a fraction. So when we're saying a rational expression, we're saying an expression with variables. So we've already learned to do a over b plus c over x plus b over x plus y, correct? We did this by getting a common denominator, just like we do with regular fractions, and then we add or subtract the numerators, okay? Likewise, if I did 3/5 times 7 over 8, I get 21 over 40. So likewise, if I have the product of rational expressions, so x over y times m over y plus x, well, it's just what? X times m over y times y plus k. And I can distribute or not, and if I want to, I get y squared plus ky under xm, or mx, however you want to write that. All right, so we're going to use these to know we're going to go backwards to simplify. So let's look at a one that's multiplying of some polynomials. So x squared plus x minus 12. And let's just use, well, I'll come back to that. Okay, all over x squared minus x minus 20 times x squared plus 2x minus 35 over x squared plus 9x plus 14. Okay, so what we have to realize is I have a fraction times a fraction. So I got to know fraction rules. So remember, these are tied together because there's more than one term. So this whole thing is a factor. So a factor divided by factor, factor divided by factor. That's why I use parentheses with different colors. So the first thing I should do, none of these are the same. But let's see if they're factorable, which we know how to factor. So x plus 4 times x minus 3 over x minus 5 times x plus 4 times, we get x plus 7 times x minus 5 over x plus 7 times x plus 2. So now I went from 1, 2, 3, 4 factors to 1, 2, 3, 4, 5, 6, 7, 8 factors. Remember, factors are times each other. So now I can look, do I have any that are the same? These two, so they cancel out because that divided by that is 1. These cancel out. Anything else? Oh, the x minus 5. So I'm left with 1 here, x minus 3, 1, and x plus 2. So now it's numerator times numerator over denominator times denominator. And because these are tied together, you can't cancel out these x's, and that's simply your answer. All right, so let's try dividing. So likewise, when we said x over y over, this is a complex fraction, we said we can, this is, if we think of this as the numerator and this is the denominator, okay, and as long as I multiply by some form of 1, I can have the same, I don't change this value. So if I want to make this 1, I can multiply by its reciprocal, correct? That will give me 1 down here. But remember, it's still a fraction, so I've got to do the same thing up here. Well, I know these cancel out to 1, then I'm just multiplying fractions. So numerator times numerator over denominator times denominator. So then I simplify this from a complex fraction to a regular fraction. Likewise, I could have rewritten this as x over y divided by k over p, and I'm going to keep, change, flip, and I'm going to get x over y times p over k, which I get the same way. I've just contrived this problem. It's just the way how I look at it. So let's look at a complicated one with polynomials. So x squared minus 6x plus 8 all over x squared plus 3x minus 28 divided by x squared minus 2x minus 15 all over x squared plus 2x minus 35. So what do I need to do here? So I'm going to factor each one. Well, first of all, I'm going to put my parentheses, and I'm going to change this to what? Keep, change, flip, x squared, so I don't mess up. Because if I factor now, I might forget to go back and do the keep, change, flip. It's still a fraction divided by a fraction. You've got to follow fraction rules just because they're complicated polynomials. So now I can factor these. Yes, so I get x minus 4 times x minus 2 over x plus 5 times x minus 3. No. Oh, this is 28. I was like, this didn't make sense, which is 4 and 7. So this becomes x plus 7 times x minus 4 times x plus 7 times x minus 5 all over x minus 5 times x plus 3. So now I look, do I have any terms that I can cancel out here? So the x minus 4's cancel out, the x minus 5's cancel out, x plus 7's cancel out. Now I'm left with x minus 2 over x plus 3. So it's a division problem, so we have to do the keep, change, flip first, and then factor, and then simplify like it was a multiplication problem. So we have one more to try. So that's going to be x squared plus x minus 6 all over x cubed minus 2x squared minus 35x divided by x plus 3 over x squared minus 7x. So the first thing I'm going to do is I'm going to keep, change, flip so I don't forget to do that because I have a short-term memory and I might, times x squared minus 7x over x plus 3. Then I'm going to factor. So this factors, the numerator factors to x plus 3 times x minus 2 over, I can factor out an x, which leaves me with x squared minus 2x minus 35, which factors out to x minus 7 times x plus 5. Here I can factor out an x, so that I'm left with x minus 7. Here I just have x plus 3. So now I look, do I have any common factors? These x's, x minus 7, x plus 3. So I'm left with what? X minus 2 over x plus 5. All right, but you got to use your parentheses because otherwise, even here, I don't feel comfortable writing these without parentheses because then I'll forget and I'll somehow combine them and make higher chance of error. Stop the video and do the practice problems and the problem set.